already joined us.
Participants, please join with your name which is registered. There are some participants who looks like their name displayed as meeting guest. We can't identify them. Please.
Welcome, sir. Is it audible, sir?
Sir, તમારો કેમેરા ઓન કરો. રવિ સર.
મારો on જ છે.
કેમેરા is not on.
મારો on જ છે.
Camera is not on.
હવે
હવે આવી ગયું.
Yes, do you hear me?
Yes, yes.
Yes,
Welcome,
sir.
sir. Welcome, sir.
Thank you.
We start just after few moments.
Okay, no problem.
Participants are joining.
Okay.
Please turn on your webcam, sir. Can we start, sir?
What? Do you want to start now?
Yes.
Yes, sir. Most of the participants have joined, about 85.
So can we start, sir?
We can start, sir.
Okay. So can you see my screen?
Yes, sir.
Yes, it is visible. It is visible.
It is okay.
Okay. So I am introducing our foreign speaker, Mahmoud Elsisi, a senior member IEEE, received the BSc, MSc, PhD degrees from the Electrical Engineering Department, Faculty of Engineering, Sabura, Bena University, Egypt, in 2011, 2014, and 2017, respectively. He worked as an assistant professor at Electrical Engineering Department, Faculty of Engineering at Sabura, Bena University from August 2019 to July 2022. He worked as an assistant with the Industry 4.0 Implementation Center, Center for Cyber Physical System, Taiwan. He is currently an associate professor with Electrical Engineering Department, nationally Kaohsiung University of the Science and Technology, Taiwan. His research interests include the control system, neural networks, fuzzy logic, Kalman filter, observer, IoT, cyber security, and many etc. Many large field of research work. So I invite Dr. Mahmoud Elsisi for expert speaker for the topic of IoT and its applications. Thank you, sir, accepting our invitation. Please, sir,
Thank you very much.
Share your knowledge about IoT and control systems and correlate the field of IoT with control systems. Thank you, sir.
Welcome, sir.
Thank you for your introduction. So I am happy to introduce these lectures today, and thank you for your invitations. I am Mahmoud Elsisi, and I am working as associate professor in Department of Electrical Engineering National Kaohsiung University of Science and Technology in Taiwan. I will introduce lectures about reliable Internet of Things architectures with predictive control and machine learning against cyber attack. I I was working as assistant professor at Benha University from 2017 to 2019, and also I was working in National Taiwan University of Science and Technology from 2019 to 2022. Uh, from 2022 until now, I am working as associate professor in National Kaohsiung University of Science and Technology. Uh, my research interest in different topics related to motion and control, model predictive control, and also decentralized control of large-scale systems and the machine learning applications, artificial intelligence technique, including optimization techniques and meta-heuristics techniques, and also cybersecurity for microgrids and for electric vehicle systems and Internet of Things applications for industry for application systems and power system economics and renewable energy also. Also, we work in power system dynamic stability and control and nuclear power plant control and wind energy conversion systems. For Internet of Things, we use contact element. This it is software supported in collaboration with Germany company. The name of the company Contact Software, and this platform we used in our project can support the digital models for the systems and also can help us in product management and the digital product application. And they used in many applications. This contact element, I will show you how we can use this one. And if you're interested, you can contact me. And we already have the IoT server in our school in National Kaohsiung University of Science and Technology. And this software can do more features and more functions. In these functions, we focus only to use in Internet of Things technology and the digital twins for the machines. So for Internet of Things, they have many, modules and many functions. I will show you what is the solution. This solution related to the IoT layer, model, and overview of functions. Also, how we can do data management for the processing and the providing data. And also, I will present what is this modules related to digital twins and application of this component in our project. And I will show you some live demo and will show you discussion and reference that we published from these applications. Uh, First of all, contact software IoT digital twin overview.
Sir,
As you see
sir,
here,
hello, sir. Uh,
yes,
currently you are on first slide.
but I already shared. I
Yes,
am
but
in
yes, yes. Now it's moving. Now it's moving. Okay, okay, okay,
because I do slideshow, so to open all screen. So
okay.
now it is You can see now.
Yes, yes, yes. Context software IoT digital twin overview. Yes. Okay.
So this one you can see.
Yes, 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 sir.
Okay, okay. So here I will introduce a solution architecture of contact software and will show you what is the digital twin used in this IoT platform and how we do data management and processing and the application component. And I will show you live demo and we'll discuss what is the result from these applications. Here for contact software IoT digital twin overview. Here we used some sensors in the machine to collect the data. Then maybe you have different sensor with different format and different protocols. We try to send here in some gateway. This gateway try to change this different format in another format and use HTTP and MQTT protocols to transmit this data to the IoT platform. So each device collects the data from the machine as we see and sends this data to the database server to overcome the different communication protocols of the sensor. Then the gateway here classify the collecting data. We can use machine learning to classify this data and what is features of this data and if there is fault or there is any mistakes in the systems, the AI can classify this data in this gateway and then send this result using MQTT protocol to monitor what is happening in the machines in the dashboard of the industrial digital twin platform. After we receive this data in the platform, this platform can do data visualization and also we do condition monitoring and can do data analysis and fleet management and production optimization and also can do management for the software can do closed loop control and uh, go back to the machine if there is something happen and try to control the machine based in the received data that they analysis and based in the result. So here, the architecture of contact software. Here we have some assets, sensors and actors and controllers and the machines. This is the data source and also receives the data if we send signal back to the machine. After these assets, we have connectivity, communication standard, protocols like OBC, U and S7 and Mobus, and MQTT protocols, HTTP if we receive data also from some camera can receive the image and analysis this image. So you can receive any data, type of data, raw data or image anyway and send this using uh, communication standard. And after this one, we go to data processing and check what is happening in the machine and do analysis for the data. Also can use this data for any future, work like if we want to predict something trend, if work in energy system, wind system, we can do some prediction like maintenance, any thing need prediction based in the collecting data. So here, overview of functions of uh, the architecture. Here we have the assets, these assets like sensors in the machines, and then this sensor maybe have different format. Some image, maybe raw data, different way. So we go here in the gateway. This gateway try to organize the format and using MQTT, uh, using maybe JSON format, any format suitable to arrange the data. Then MQTT sends this data to the data processing systems. This one try to arrange the data. Maybe this data come from different machine. Try to organize the data and also the event that happen in the system. And after this platform has data provider and database. If you want to download the data at any time, you can download. Also in the digital twin system, have trigger this one to do some alarm, do some alert for the users. If there is any problem happen in the machine, can it change the status and do some actions. Also there is some applications so you can share this information using emails. If there is something happen, can inform the user by emails, by sharing the task between different engineers in the factory, and show what is happening and share the task to solve the problem if there is any problem in the machine. Also, you can see the diagram, activities, and workflow document about the machines in the IoT platform. So here this machine, we have some digital twins for, any machines and try to compare the real data and the digital twin and simulated system and to take good decision. So here, this is the real asset. So in the IoT platform, we have digital, models. These digital twins try to compare between the measurement data and the simulated system and the database. And if there
Sir,
is
sir,
something happen, yes.
please, sir. Right now you are on sixth slide.
So
There is
why?
slide is not moving, I think.
So maybe there is problem using this. Team. Why?
No,
Okay,
you
maybe
you can put on slide slow, slide show.
I already did the
You
slideshow.
activate your slide show.
I already activated slideshow,
Okay.
and but I move. So now it is moved.
Sir, please answer screen and reshare the screen. Then it will okay.
I
Answer
reshare
this screen.
again.
Yes, yes,
So okay, now it is moved,
yes.
but I
Move.
already it is moved. The last time I check with you, it is moved the same way. You so now okay, it is moved. It is moved.
It is moved on 10th slide.
Ah, right now we are so we saw 10th slide.
So number 11, no?
No,
No, you
Okay,
answer the screen and then share again.
okay,
Then
okay.
it will okay.
Stop. Okay, I will stop. Okay,
yeah.
Ah, now share again.
okay. So share window or share enter screen, which one it is better for you?
Sir, it will be better to share entire screen and then
Okay, okay. But enter screen, okay, not accessible here. When I select enter screen, no share.
We have
Okay.
been given full.
So so now,
Yeah, yes, sir.
Yes, yes,
Yes,
okay,
now it is showing.
yes. Now you open your slide.
okay. So let
Okay,
me.
and now slide show.
Yeah,
Yes,
I
Yes,
did
sir.
it.
yes. This is
Okay.
okay, sir.
So
Fine.
now move.
Data model. Yeah,
Okay,
it's a
it is a
change.
change. Okay,
Yeah, it is
okay,
changing.
Yes, it is
okay.
changing.
So
Yes, sir.
we come back from here. Okay, so the
Yes,
architecture. Here, overview of functions.
Yes,
So here we have sensors in the machines, and then after receive this data, this gateway try to organize and changes the format of the data, and then use MQTT protocol to send this one for the cloud. Okay. After we receive in the IoT platform, we do some transformation. We save the data, we customize the data and arrange the data. And then also you can, there is data provider in the IoT platform to download the data and know what is happening in the system. So this data provider try to save any event happen in the system, and also there is trigger this one try to do actions if there is something happen abnormal, okay, and try to send the message for the user using some applications, maybe emails, can send the message by emails, uh, and also can share the activity and the tasks between different users. So here in this solution, we have digital twin, and this digital twin try to compare between the received data from the machine, the real one, and compare this data with the historical data in the machine, and try to take the good action based in the received data. Also, this digital twin can work with different kind of applications like cars, maybe robots, factory also can work with energy systems, so can work with any kind of application. So here in digital twin system, it is a virtual representation of real asset. So here, this one, it is like virtual representation of the real assets and describe the current construction and operating condition of the assets. Also provide usage and environment data of the asset and allow remote adjustment and control of the assets. So here in the digital twin, we try to simulate the real one and try to compare receiving data with the digital twin model, and try to allow remote adjustment and control of the assets. Here also in the process, here this IoT platform has different thing, has data processing. This process describes what is happening in the machine every time, and do to model management and overview, and have some diagram also to show what is happening corresponding time for the real asset, and also can process parameter fairly and application specific defined, so can do any definition and they can do specify any application and what is happening in the machine. Also, this IoT platform has flits function. Flits function, if you have groups of assets, these groups of assets has the same job, do the same job. Like if you have platons of vehicle, if you have some, robots do the same job together. So this IoT platform can help us to control these all groups together. So the fleet is a group of digital twins that share certain characteristics, rule-based, and function possibilities, overview, navigation, and do control anything like this. If you have some platoon of vehicles, so you can control together if these have the same characteristics. So here also you can represent the environment layout of your factory, and this it is real, simulated representation for the real factory. Here in the environment, you can see the sensors from each component, and if there is some sensor has some problem, maybe you will see this sensor red. So the red one, it is has problem, maybe the green one, no problem. So it will be easy to monitor the factory and know where is the problem using this IoT platform, and can show you the location in the same factory building. If you control different sensors in the building, can show you where is the problem and where is the location of the problem. Also, you can use something we say digital master. So digital master serve as template to if you want to change anything. Maybe you can take copy for this one. If so, it is like template for different digital twins. This one also can for navigation and the control and the evaluation. And also this one has another thing, not only digital twin, can do also data management process.
Please, sir, turn on your mic. Turn on your mic. Hello. Sir, turn.
Automatic. Okay,
Yeah,
so
okay, okay, sir.
okay, before it is okay or long time you can't hear.
Some two lines missing.
Oh, so if there is any problem, let me know and I check because maybe
Okay, I
it was
have.
automatic.
Okay, sir. Please reshare your slide.
Okay, okay. So, okay, if any problem,
Okay.
please let me know. Okay,
Put on slide slow. Slide slow. Okay. Okay.
okay. From last one here, you can't hear or
Yes,
which
yes,
one?
yes.
This
From
one?
here, from here. Yes.
Okay. So this, IoT platform also has some function, digital master. This digital master, it is like template if you have similar digital twins, so you can control from one. Okay, we say digital master, so this serve as template for instanted similar digital twins. Maybe no need to control each one alone, so you can control only one and send for all at the same time. So here also not only digital twin in this IoT platform, also they can do data management and processing and providing the data. So here, if we have different type of sensors or different type of machines, so you can organize the data here. You can receive the data from all at the same time, and this, IoT platform can help us to arrange the data and to know from where this data come. Like for example, if we have robot arm can arrange. So if you wanted to know the status of robot arm, you can go in robot arm only. And if you have conveyor and something other, so you can arrange the data and do, I mean, also if the data has different unit, like maybe time, maybe any other unit, so can arrange this data. So here's the stream operation of digital twin defines the data processing chain for each payload type, like telemetry and event data. The function here, transformation of data before saving. Okay, so arrange the data before saving and also do action if there is any problem, automatic creation and the completion of process, for example, data individual definition of the storage location. So can work with data management. In this IoT platform also has the function of trigger. If anything happen, can, I mean, change the status and do alarm for, I mean, the user. So the trigger of digital twin automatically detect expansion status and generate predefined reactions. Okay, and send maybe message for, I mean, the user. So there is different degree of, severity, configurable, warning, error, fatal error, reaction, anything. And you can send email for the user if there is any problem. Also here, if you want to download the data, so they have database. Okay, so you can download the data at any time to study the data, do any processing, do any forecasting and the prediction for the machine. There is also some features here in the IoT platform, the diagram. So you can present the diagrams for any, I mean, data, receiving data and visualize the time of series data which is stored and provided in the digital twin. So also this can change. You can do multi-curve together in the same figure, and you can compare between the data. Receiving data also has different function. Maybe you can do different curve with different, I mean, colors, and you can see the real, I mean, situation and the current situation from the machines. Also, if you want to download any type of data from any assets, you can download as you like. Here you can go in data download, select which data you want to download and study, and you can specify also which time you want to study the data. For example, you receive data 1 year, so I don't want this all year. So you can select which months you want and you can download only the months or the years that you want. And you can download the data in CSV file or JSON format. So the data here used only for if you want to do any external analysis. Here also there is application component for IoT software. in home, you can uh, see any, I mean, if you have different factory, different branch in different city or different country, they have the map here show you maybe our machine in this city has problem, another machine in another, I mean, city no problem. So we can share the tasks and share the information together between different users in this IoT platform can manage different, I mean, factory at the same time and share what is happening and try to share the information like this. Also, if you want if you are new in using I mean, the application and you need to know some information about some machines, you can do search in the IoT platform and for example, you will find all details or document about this machine and you can know the history of the machine from the IoT platform. So here we can do condition monitoring. Also, if there is any problem, there is some traffic light will change. This can change to different, I mean, color. If red, if yellow, according to the status. So enable automated monitoring and visualize. And you can see this because you can access the IoT platform from different place. So you can open and see the status from any, I mean, place. And also, if you don't want to open the IoT platform, you can send what is happened using the email. Also, in this IoT platform, you can use 3D view. So you already have the 3D of the machine. And if there is some problem in the machine, you can know the problem where is inside the machine, and you can share this information with other people. So sharing view with redlining like this. And here anyone in the factory can know what is the problem and where is the problem more accurate. In the machine also in the IoT platform, we can share the tasks and we can know what is happening from sharing information between different user or different partners. Also, in this IoT platform has edit trial. This one here you can go and in this one and contain all changes to the digital twin and sub element and show you what is happening and what is the date and what is the action uh, date and where is also the place. Here also maybe can classification allows the organization of all business object, digital twin, process and environment. So you can have different thing and classify all of this. And also here you can upload document about the application. If someone need to know any information about the machine, he can download the document and understand about the machine and compare the receiving data based on the information in the document. If there is any variation, he can understand what is happening in the receiving data. Also can do workflow. So here we can share the tasks in the machine using workflow. There is administrator and maybe another people can be like user, another people can just monitor. Okay, so you can define what is the job for each one. So here the task is all task attachment directly accessible, so anyone can go and know what is his task. So only all of this related to the IoT platform. So how we use this one in our research? So in our research, we used this IoT platform for energy management of different component in our industry for in National Taiwan University of Science and Technology. Here we have a factory, we have different machines and CNC machines, and we have automated guided vehicles, and we have power meters, and we have air conditioners here. So we try to monitor all of this to know what is the activity happen in the factory every time and how we can save the energy. And this one, it is our dashboard. And here it is live demo. So here from the dashboard, if I need to know what is the status of, I mean CNC machine, I can only click in CNC machine, can go to CNC machine. If the AGV, I need to know the status of AGV, anything, I just click and later go to know the status. So here only we try to monitor what is happening in the machine. So we can monitor all factory at the same time and where is the position for each one. And we create assets for each one. So here also we monitor the temperature. If someone forget to close the air condition, anything we can know, and we can try to save the energy and alarm them to close the air condition if they forget anything. Another applications here we used to monitor the AGV and to control the AGV remotely. And here we receive the data from the AGV and send this data to the IoT platform, and then we can do analysis for this data. If there is any cyber attack, the machine learning here can show us if there is any losses in the data, if there is any cyber attack in the system, and try to publish the status here. So if the status it is normal, no any problem, so we say normal and secure, no any, I mean cyber attack. If there is also no losses in the data, we can know there is no losses in the data. So here this it is our AGV, and this it is our IoT our IoT dashboard. So here we can see here we control this one. Just here we try to analysis the data. Okay, no navigation for the AGV. So here from in the IoT dashboard, we can see the status. Uh, okay, this is another video. we control this one using a robot operating system. And here is the status. We do refresh. So the status here change. And if there is problem, we will see here, I mean red color. Okay, so here only do analysis for the data and show if there is any problem. Okay, so if there is problem and there is cyber attack, the cyber attack will try to send some signals. I mean, not correct for the AGV. So maybe we'll do some accident, do anything in the factory. Okay, so what we can, how we can solve this problem? Okay, so we used model predictive control. So here we consider the cyber attack data as disturbance in the machine. Okay, so if there is some disturbance in the data, the model predictive control can adjust the signals for the AGV, the automated guided vehicles, and try to keep this one track in good way. As we see here, we designed the model predictive. If there is any problem at the beginning here, the AGV go in linear path. Okay, at this time, there is some, I mean, cyber attack data or false data. The model predictive can try to control and make the AGV go in the reference bus again, back again to the reference bus. Here, if we used a traditional BID controller, when there is cyber attack data, the AGV will go random like this. And so here, in this one, in case of fake data injection, in normal case, the model predictive, there's no any cyber attack data. Okay, so model predictive can effectively control the AGV go in the linear bus with a small error compared with BID. In case of cyber attack, model predictive can still maintain the AGV go in the correct bus compared with BID. Also, if there is losses in the data because we control the AGV remotely, so maybe the Wi-Fi and the internet not good much. So if there is any delay in the data, the model predictive no problem can keep the machine go in the good track. However, the traditional controller can't go in the correct track like this. So here we try to monitor, analysis the data, and also we try to protect the machine from any false data and also from data losses using model predictive control. So here is the result in case of normal and in case of there is data losses. So this is the dashboard. If there is cyber attack data, so after we analysis the data using machine learning, we can inform the user about what is happening in the autonomous vehicles or automated guided vehicles, and he can know what is the status. The status now it is abnormal and there is red color and there is cyber attack. If the status it is normal, so no problem. We can see here the status it is normal, and we can see also the speed of the vehicle and the angular speed of the vehicle. If there is losses, there is another situation here. You will see yellow color for the traffic, uh, I mean condition, and the status it is abnormal and no cyber attack, but there is losses data in the system. We applied also this IoT platform for monitoring uh, BV systems of different macro grid. So we receive the data from the BV system and then we go to machine learning to analyze this data and to know what is the status of uh, BV system because we have some cooling for BV if the temperature it is high, if the temperature it is low, and we check if the cooling system work or not using IoT platform. So here we can check if no cooling for the system, we can know and also what is the efficiency of the BV system and what is the output power. If there is cooling, the cooling system work, we can see there is cooling system and the cooling system it is work and we can see what is the efficiency, what is the power, how much. If the I mean BV system not work, we'll see it is out of service, okay, like this, and do alarm for the user. Maybe there is some problems in the BV system. He need to check. Also, we analyze the data because we need to make reliable IoT. The main problem of IoT it is the cyber attack. So also we consider to check if this data it is correct or false data. So if the data it is false, the machine learning can know this data it is false data and also inform the user about the problem. There is fake data. So any data come, it is not real data. He need to take care about the maintenance of the network. Also here we applied IoT platform for reliable indoor position of automated guided vehicles. We used Internet of Things and deep convolutional neural network. This one also we consider the adversarial attack problem. Here we try to predict the position of the AGV in indoor position because in indoor position you can't use GPS. So you only need some system to uh, find the location in the factory of the AGV because you can't use GPS inside the factory or in indoor. So here we try to estimate where is the position of the AGV using the Wi-Fi signals and try to predict where is the AGV. So here we do training offline first, and after create the model, we consider also adversarial model to make our model robust against any adversarial attack. After we create the model, we use this model online. So here only receive the signal strength of the Wi-Fi and try to we have many Wi-Fi point in the factory. We try to predict where is the AGV based in the signals that come from the Wi-Fi and know where is the location and we can track the AGV in the factory. So as we see here, we have the Wi-Fi modules. This one we send the signal. This one already AGV has computer board here in the AGV. This one connect with the Wi-Fi and then we have analysis for the Wi-Fi signals. We receive these signals in the IoT platform and then we analysis we can know X and Y position of the AGV in the factory like this. So here the AGV can go anywhere in the factory and then we can know where is the AGV position. So that is all of our application and about IoT platform and using controllers and indoor position and the monitoring of uh, PV systems. And this is our recent publication using the IoT platform. We published a paper under this title and Internet of Things based deep learning architecture to secure automated electric vehicles against cyber attacks and data losses in IEEE transaction in systems and demand and cybernetics systems in 2024. And also we have one paper under this title, Robust Indoor Position of Automated Guided Vehicles in Internet of Things Network using deep learning, considering adversarial attack. This paper published in IEEE Transaction in Vehicular Technology 2024 also. Another paper under title Drone Acid. We have some drone. We try to monitor the ship emission in port system. We create IoT architecture using deep learning, try to analyze the data and monitor the ship's emission in port area. And we publish this paper in IEEE transaction in instrumentation and the measurement. Also, we have another application. We used the IoT platform and publish one paper, design of reliable IoT system with deep learning to support resilient demand side management in smart grid against adversarial attacks. So here we try to monitor different microgrid and try to analyze the data and inform the main grid about the demand side, I mean consumption and generations. Another paper, we do this paper in collaboration with Finland, some author from Finland. It is under title Effective IoT based deep learning platform for online fault diagnosis of power transformers against cyber attack and data uncertainties. This paper tried to monitor the status of power transformers in electric power plants and see if there is any problem in the transformer, can inform the user. And this paper published in measurement in Elsevier and other applications. We collaborate also some people in Finland, some people from Vietnam. This paper under title online, I mean monitoring of digitalized gas insulating switch gear against cyber attack, also used machine learning, and this paper published in IEEE Access in 2021. And we have other applications. If anyone interested in our solutions, anyone need any help, um, we can collaborate, no problem. We are open for collaborations. And we focus to design robust IoT because the main problem for IoT it is a cyber security problem. So we try to do monitor and also do mitigation for the cyber attack problem. So thank you. And if you have any question, we can discuss.
Thank you, sir. Thank
You
you,
are
sir. Participants have any question? They may ask.
Please write into the chat box.
If any question, they can write in chat box also.
If you any question, also later, maybe you can send for Dr. Rafish.
Yes.
and he can send for me maybe if any, I mean, question about the applications, if someone interested to collaborate in these applications, uh, you can contact Dr. Ravish and he can contact me.
Okay. Sir,
So,
I have one question, sir.
okay.
Means yeah, if you can we correlate this IoT algorithm with Kalman filter, extended Kalman filter?
Yeah, we can work with any, I mean, type of filters. You have the filters, maybe we already used the Kalman filter in the published one paper in IEEE robust Kalman filter. We
Yes.
can use this one, but we need, L norm. L2 norm to know if there is cyber attack in the data. So the Kalman filter, we take this one and do L norm, and we can know if there is cyber attack in the data or not.
Okay. So
So
can we develop a security-based Kalman filter?
yeah, we can do
Security-based.
this. Yeah, we can do this. We are interested also of this. If you have some, I mean, background about this filter, we have
Hmm.
project here in with the government. We
Hmm.
wanted to monitor the data of microgrids, different micro electric vehicles in microgrids. We are interested to apply Kalman filter, and we already applied Kalman filter before. Okay, we are
Okay.
interested again to develop good, I mean, filter and observers. We can,
Hmm.
because IoT platform, it is for monitor. So only you need some theoretical contribution for how we can detect the attack, how we can do mitigation for the attack. So the filter can help us. For example, you can predict what is the disturbance in the system using the filter. Okay.
Okay.
Then if this disturbance you can predict in good way using the filter, we can connect with the controller. The controller can help us to take the action based in the filter estimation. For example, you want to estimate all states of the system. So we receive some data, you help us to estimate other states of the system. After we estimate, we can know how much disturbance in the system happened, like cyber attack. In this way, if you know how much cyber attack or how much disturbance happened in the system, we can provide this information to the controller, like model predictive, any other controller, and the controller can do good action because for IoT, we try to monitor remotely. Okay,
Yes.
so we need to have some, I mean, maybe microcontroller. This microcontroller has some Kalman filter, have other, I mean, control technique and do processing for the data, and we can back again for the, I mean, the device, like electric vehicles anyway.
And we can also develop a privacy preserving algorithm. Privacy preserving. Hello?
Yes, yes, I hear you.
Privacy preserving algorithm. We can develop also privacy preserving
Yeah,
algorithm.
yeah, we can do this, but for I'm focus much in control side
Okay.
because not focus much in software side.
Okay.
I mean because there is communication part. For my, I am electric engineering. I am focused to handle the data, what is happening in the system. If there is disturbance, anything, I can try to adjust the control signal for the machine. For the
Okay.
network side, if you wanted to do this, maybe we can do blockchain.
Hmm.
Maybe we can focus, but it will be telecommunication part.
Participants have any question? Uh, they can write in chat box also. If any question, Then they can write in chat box. Sir, you can see chat box also, sir. There is appreciation from participants.
No questions. No
They are
questions.
appreciating you. Please unshare your screen, sir.
Open my screen.
Unshare your screen.
Unshare. Okay.
Okay.
It is unshare now.
Okay. Yes. Fine. Sir, one group photo with our participant.
Okay.
Okay, please, participant, please turn on your camera so we can take one group photo with our foreign expert. And if participants have any question, they may ask. Okay, sir. So it was nice session delivered by the Dr. Mahmoud Elsisi, and
Thank you very much, sir.
nice demonstration given by the Dr. Elsisi.
His voice.
कौन बोला?
Hello.
एक मिनिट स्लीपिंग टूल झालं.
Hello.
Please mute your voice.
Chirag, mute your voice. Okay. So thank you very much, sir, for accepting our invitation and deliver nice session. Thank you, sir. We will arrange some lectures, some more lectures in future for ATAL FDP. And this is the Indian government mission, ATAL FDP. So thank you, sir. Thank you.
Thank you. You are welcome.
Thank you very much, sir.
Thank you.